All right, so let's try to use de Moivre's to get the octuple angle formula for cosine. Okay. Oh my God.
No, wait, never mind. I thought it was an oh my gosh moment, but it's not.
No, it kind of is. So first things first, you're going to need Pascal's triangle to a few spots, so go fetch that. So 1, 1, 1 to start, then 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. When I screw this up, shout at me, okay? 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1. Finally, the row I need. 1, 8, 28.
Wait, don't you only need 8 rows?
56. Yeah, I need the 8th row.
Oh, it starts at the second row then?
Yeah, I need the 8. This is the 0 row. So the 0 row, the 1 row, the 2 row. So I need the 8 row.
70.
70, 56, 28, 8, and 1. Okay, so I need that row. So don't let me lose that. Okay, next thing. What's the next thing I need?
You need Euler's identity.
Yeah, I need de Moivre's formula, or I need Euler's formula.
Yeah.
Euler's.
Okay, so I need one or the other. I don't care which one you use. I'm going to use de Moivre's, I guess, because I seem to remember it, which says cosine of n theta plus I sine n theta is cosine theta plus I sine theta, all to the n. And I need n to be 8. So I should probably just put 8s in. I don't know. Okay, so equals what?
Coefficients.
Can you ask them to take their conversation around the corner or something? So equals, first thing,
What cosine?
okay, good.
Cosine of 8 theta.
Write down your row from Pascal, right? So you have 1,
Cosine
8, 28,
56.
56. Oh, that's not enough space.
Yeah.
56. Then in your next row you have 80, 56,
You have 70, not 80.
70, not 80. Duh. 70, 56. I told you guys not to let me screw this up.
We didn't.
28,
We told you.
8, and 1. So I got all of these guys scattered out, right? And then the first one is your cosine of theta to the 8th.
What?
So cosine to the 8th of theta.
And
Then you need to add,
8 cosine.
To the 7th power.
so you have cosine to the 7th theta times I sine theta to the first power. Let's call that.
Cool.
And then I need plus 28. And then I need
Cosine.
cosine to the 6th of theta times I squared sine squared theta. Right, so at each step, I'm trading one of the cosines for an I sine theta. Right, I'm trading one of these for one of those.
Oh, okay.
And you always have to make sure you include.
You guys all see that?
Yeah,
And then, I'm making sure to put the exponent on the I.
And both
So
exponents
your
should
first one
always
was
add
0,
up
then
to 8.
it's 1, now
Yeah.
we're at 2.
Yeah.
Okay.
So then this one's going to be plus, and there's 56 of these, and they're going to be cosine to the 5th theta times I to the third sine cubed of theta. And these guys, right, the 5 and the 3, those are always going to add to 8. Right, so you can always check whether you're kind of dorking it up. And I have plus 70
Cosine 4.
cosine to the 4th of theta, I to the 4th, sine to the 4th theta, plus 56 times
Cosine to the
cosine cubed I to the 5th, sine to the 5th theta, plus 28
cosine squared to I6
cosine squared theta times I to the 6th, sine to the 6th theta, plus 8 cosine theta, I to the 7th, sine to the 7th of theta, plus 1
I to the
I to the 8th,
theta
sine to the 8th
theta.
theta.
No. Yeah.
Okay,
That's a lot.
now
Your signs.
I just wanted the sines, right?
Yeah.
So all I want is the cosine part of this, right? Sorry, I said sine, I meant cosine.
Yeah.
Right, because all I wanted was the octuple formula for cosine. I have here the octuple formula for sine as well, I just don't care.
Just gather the cosines disregarding the I.
So not gather the cosines, gather the things that are not with i's on them.
Yeah.
So
So there might be things with I. that-
this thing obviously doesn't have an I in it. The cosine to the 7th times I sine theta,
does have an I.
definitely has an
that guy definitely has an I in it. So that one's not going to be needed for me. Because I don't care about the sine part. I don't care about the, sorry,
Second
I
one.
keep saying sine. I meant, I don't care about the imaginary part.
The third one does because I squared is
The I squared will simplify to -1.
Okay, so I squared is really -1, thus this becomes important to me.
and
The third one's
the
not
third
important.
one not
And
because
I cubed is
still
negative I,
negative I.
right? That's I cubed is I squared times I.
Yeah.
And I squared is -1, so I get negative I out of that. So I can cross that part out. Oh, what am I noticing?
It,
Yeah, the even ones I'm going to need to keep, the odd ones I'm going to pitch. So I'm going to keep this one.
Yep.
I to the 4th is
positive 1.
+1. Right, -1 squared. Then the next one's going to have an I left in it, so I can just drop that guy. Then the next guy's I to the 6th.
It's going to be -1.
That's going to be -1 because it's -1 times -1 times -1. So I'm going to need that part. And the next one I'm going to chuck it.
Chuck it out.
And the last part,
You leave it because it's sine,
I to the 8th is,
but it's sine though.
but it's sine. But I don't care whether it's sine or cosine. I just care whether that's got an I left in it or not.
It does.
So I to the 8th
Does not.
does not. Because it's I to the 4th times I to the 4th, and we just decided over here I to the 4th was +1. So that's really a +1. So I'm going to need that part.
Oh, okay.
So in the end here, what I get is cosine of 8 theta is, and then I need to collect all the green bits. So I got cosine to the 8th of theta, this guy,
Plus
plus
minus.
minus 28 cosine to the 6th sine squared. And then the next bit didn't count, and now I have 70, right? So I have plus 70 cosine to the 4th sine to the 4th. And then minus 28. Oh, and I could check, right, that my signs are alternating, which they should be. So I got a +1, and then a -1, and then a +1, and then a -1.
Wait, so why are they switching to positive and negative?
They're switching because it's i's.
Oh, okay.
right? Because the powers of i's are going to alternate between, they're going to go plus, plus, minus, minus.
Okay.
Plus, plus, minus, minus. And then I discarded half the terms. So they should go plus, minus, plus, minus, plus, minus. So I got my minus 28 cosine squared theta sine to the 6th theta. And then at the end here I have plus sine to the 8th. So that whole business is the octuple angle formula for cosine.
Very nice.
Cool.
Seems legit. What's the highest you've ever like needed to go? Like,
Needed?
yeah.
I was a pure mathematician. I just knew that these formulas existed. I never used them for anything.
What do they use them for?
What do they use them for?
Yeah.
They use them for calculating exact values for trig functions to funky little angles. So basically high precision. If you actually need high precision, these things come in handy a little bit.
So is that whole thing more precise than just cosine 8 theta?
It's easier to calculate than cosine 8 theta. Trust me. The cosine that the calculator gives you, right? That's a numerical approximation. If you need really high precision, you want something like this so that you can keep those exact values kicking around instead of doing the numerical approximation.
Can you explain again how the red, like how they cancel out?
Oh, why am I dropping the red ones? So I'm dropping the red ones because this one, like this 8 cosine to the 7th times I sine theta, that's going to have an I in it, right? Like regardless of whatever's there, there's an I in there. This sine part, that also had an I in it. So I'm using the I's as markers. So the things without the I's are going to go together, right? That's all the green stuff I underlined. And then the things with the I's are going to go together. So if I wanted the octuple angle formula for sine, I would have been collecting the things with the I's in them instead of the things without. But you're always going to collect one or the other.
Okay.
And if you want the cosine one, you want the ones without I's. If you want the sine ones, you want the ones with the I's.
I see. Okay.
It's a cheap trick.
That makes sense though.
You guys all good with that?
Oh, and the eyes are always plus, plus, minus, minus, plus, plus, minus, minus, plus.
Yeah, and the pattern for I always goes positive real, positive imaginary, negative real, negative imaginary.
Oh, so then you could just, on it, so if you wanted sine, you could just cross out the first one, keep second cosine.
Yep,
And it'll work
exactly.
that way every
Yep.
time if you want cosine.
Yeah, you just need to think about the signs, right?
Yeah, and you just have to know the I to know who that.
Yeah, so if you follow the sign pattern, this is going to be plus 1, right?
Yeah.
This is going to be plus I. This one's going to be minus 1. This one's going to be minus I. This one will be, that's 4, right? So I come back to the beginning, so I do plus 1. Then this one would be plus I. This one would be minus
1.
1, of course. Then this one would be minus I. And then this one would be plus 1 again.
So then really you don't even need to know, you don't even really need to understand I, because you can just, the first
No.
one's positive.
I would argue that on some level, knowing this 4-part pattern repeats is understanding I.
I guess, yeah, plus plus minus.
But yeah.
But you just
Yeah,
need
you
to
could
know.
just memorize this 4-part pattern, and that would also be fun.
Okay.
So it's just knowing what like e to whatever exponent, I mean I to whatever exponent really equals.
Yep.
Okay.
Yeah, and then using them as markers.
Like a little grid on page 386 of your text at the bottom of the page.
Yeah, there's little multiplication tables for I's in lots of textbooks, probably this one. Any more questions on that?